Alright, in this video we're going to talk about solving quadratic equations using the quadratic formula. Alright, so the quadratic formula is a formula that you can use to solve any quadratic equation. Alright, so very important formula to know. Now, I did some other videos on some other methods for solving quadratic equations, right? We did the factoring method, I did one on the square root method. But remember, the factoring method and the square root method don't always work, right? You have to be able to factor the expression to use the factoring method, and not every expression can be factored. You know, it has the quadratic equation has to be in a specific form in order to be able to use the square root method. If you can't use either of those two methods, you're going to have to use the quadratic formula in order to solve your equation, right? So if you watch some of the other videos that I've done, sometimes I'll tell you like these formulas are not that important to know. You don't really need to memorize these formulas. This one is really important to know, right? You need to know the quadratic formula. Like I said, it will solve any quadratic equation that you'll ever see. This will work, right? Whereas the other methods don't work all the time, right? So there are some people who don't even bother trying to factor or use the square root method. Just every time they see a quadratic equation, they just use a quadratic formula because they know it's going to work every single time, right? So of all the methods to use to solve quadratic equations, this is the most important one because it works every time, and then there's some times where you have to use this method. All right, so what the quadratic formula is, if we have a quadratic equation in the form ax squared plus bx plus c equals 0, right? So real important, before we can use the quadratic formula, we have to have our equation in this form, where everything's on one side of the equation and it's equal to 0, right? So if we have the equation in that form, the solution to the equation, x is going to be equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Right, and notice that fraction bar goes underneath everything up there, so all of that stuff is over top of the 2a. Some people make the mistake of just putting that square root stuff over the 2a. The whole thing goes on top, and then just the 2a on the bottom. All right, so the a, b, and c here refer to the numbers or the coefficients that you have in your equation. Right, the a is the number attached to x squared, b is the number that's attached to the x, c is the constant that doesn't have the variable attached to it at all. Even if these are mixed up and written in a different order, like if the x squared is put in the middle of the equation and the other things are on the other sides, a is still the number attached to the x squared, right? So it's not just the first number you see is a, the second number is b, the third number is c. It depends on what variable it's attached to and what the exponent is, right? A always goes with the x squared, b always goes with the x to the first power, c is always the constant, right? So if your equation is ever written out of order, you need to make sure that you have it straight before you start plugging the numbers into the formula. Right, but then, once you have it in the right form, all you do is plug in the numbers for a, b, and c into that formula, and then you just do the arithmetic to simplify it as much as you can, and then that gives you your solution to the equation. All right, so let's use the quadratic formula to solve a few equations here. Right, I put the first one up already. We have 3x squared minus 5x minus 1 equals 0. All right, so looking at that equation, I know right away I'm not going to be able to use the square root method because I have that minus 5x in the middle there. So I'm not going to be able to get this in the form of x squared equal to a number. So I know that method automatically is out right from the start. The factoring method, maybe I could factor this. If I have a 3 and a 1 here and they have to add up to a 5, I don't think that's going to work though. And I don't want to really waste my time trying to factor it if I'm not sure it's going to work. So I'm just going to go ahead and jump in and use the quadratic equation for it. Right, so I have my equation in the proper form, right? It's ax squared, where my a this time is that 3. The bx, my b is that negative 5, and the c is that negative 1, and then it's equal to 0, right? So it's in the proper form where I can go ahead and use the formula. All right, so my formula is x equals negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. Right, and notice, even though I have the formula written up here on the board, I wrote it again here before I start plugging the numbers in. That's a little trick you can use to help you memorize the formula. If every time you use the quadratic formula to solve a problem, you actually write down the formula each time before you plug the numbers in, just that act of writing the formula down, having it go through your pencil, helps you remember what the formula is. Right. Another good thing is, and depending on what your situation is, this might be feasible or not, but if you say it out loud as you're writing it down, just hearing it go in through your ears, even if it's coming out of your own mouth, just hearing it also helps you remember it. Right. The more you hear the formula, the more it just kind of sticks in your brain. Just like a song you hear all the time, just kind of gets stuck in your head. Well, if you keep saying x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, if you just say that over and over and over again every time you do one of these problems, it'll help you remember the formula. All right, so just a couple little tricks to help you remember things. So there's my formula, and now what I need to do is plug in all of my numbers for my equation. Right, so it's negative b, but my b this time, remember, is the negative 5. Right, so that negative is included with the b, so negative b is going to be negative of negative 5. Plus or minus, and we'll simplify that in the next step. Plus or minus b squared, right, so that's negative 5 squared, minus 4 times my a, which is 3, times my c, which is the negative 1. Right, remember that negative is included with the c. All of that over 2 times a, which is 3. Right, so I go to my formula. Wherever I have the b's, I put negative 5. Wherever I have the a's, I put a 3. Where I have the c, I put a negative 1. All right, so that's plugging those numbers in. I'm just looking to see if you guys can see that in the video. Hopefully you can see all those numbers there. All right, so that's the numbers plugged in. Now that's not the end though. Now we need to simplify this, which simplifying this is just doing the arithmetic, multiplying and adding the numbers together and stuff like that. So when you're doing the quadratic formula, there's a couple of challenges to it. The first challenge is just remembering what the formula is. The second challenge is once you get all the numbers plugged in, doing all this next part, the simplifying part, correctly. And it's just a matter of taking your time. Like, you know how to multiply numbers and add and subtract numbers. Just take your time and make sure you do it correctly. All right, so negative of negative 5, that's positive 5. Plus or minus, right, that double negative there makes it a positive. Plus or minus the square root of negative 5 squared. Well, negative 5 times negative 5 is going to be positive 25. And then I have minus 4 times 3 times negative 1. All right, well, negative 4 times 3 is going to be negative 12. But then negative 12 times negative 1 is going to be a positive 12. And then in the denominator, 2 times 3 gives me 6. Right, so be careful here. Right, there's a negative here in front of the 4. Right, there's a minus in that formula. Right, that's a minus 4. And then the c is also a negative number, so when I multiply all those out, since I have 2 negatives there, it comes out to a positive 12. All right, so watch out for the signs and stuff like that. The next thing now to simplify is inside that square root, I have that 5 plus or minus the square root of 25 plus 12 is 37. Right, so most of the simplifying here involves, all that stuff that's underneath that square root symbol, first multiplying it all out and then adding or subtracting it to combine it to a single number. And then from there, if you can simplify the square root, you simplify. Now the square root of 37, that cannot be simplified at all, right? 37 is not a perfect square, right? There's no nice whole number that multiplies by itself to give you 37. And there are no perfect squares that divide evenly into 37, right? Other than 1, but 1 doesn't really help us. Right, so if I list out some of the perfect squares here, 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25. None of these numbers other than 1 divide evenly into 37. And I don't divide it by 1 because that's just 1 times 37. I still have the 37 there. All right, so when you're simplifying that square root, you look for perfect squares. And I did a video on roots a while back, so if you're not sure about how to simplify roots, look for that video I did about roots, and I think I did 1 or 2 examples where we simplify square roots and kind of work through how to do that. But in this case, none of these perfect squares will divide into 37, so that's my final answer. Right? 5 plus or minus the square root of 37 over 6. Right, so notice there's 2 solutions there. There's 5 plus the square root of 37 divided by 6, and then there's 5 minus the square root of 37 divided by 6. Right, just like with the square root method and with the factoring method, usually we get 2 solutions when we solve a quadratic equation, and in that quadratic formula, that plus or minus there, that's what gives us those 2 solutions, right? One with a plus in there, one with a minus, right? There's 2 different solutions. All right, one other thing I would caution you on when you are doing one of these problems is when you get to this point up here where you plug all those numbers in, don't just type all that stuff into your calculator to try to get the answer. All right, for a couple of reasons. One, there's so much going on here with parentheses and fractions and square roots and stuff inside that if you try to put all that stuff into your calculator all at once, there's a real good chance that you might miss a parentheses or something and come out with a complete wrong answer and not even realize that you have the wrong answer. All right, so I would caution you on that. Also, this right here, this 5 plus the square root of 37 over 6, or 5 minus the square root of 37 over 6, this is the exact answer, right? If I were to put this into the calculator, it's not going to come out to a nice number. It's going to be some kind of irrational decimal number, which is going to be just a ridiculous type of thing. So if you put all this stuff here into your calculator all at once, it's going to give you that crazy decimal number. And then good luck figuring out that that crazy decimal that you get is equal to 5 plus the square root of 37 over 6. Right? Your calculator is not going to give it to you in this form here. It's just going to give you the decimal. And usually, your teachers want the exact answer, which means actually doing the simplification by hand and getting that square root of 37 there without actually typing it into the calculator. All right, so just watch out for that. All right, so I'm going to erase this one here. I'm going to pause the recording, erase this, and put up another example where we work with the quadratic formula. All right, here we've got 4x squared plus 12x plus 9 equals 0. Once again, it's a quadratic equation because we have an x raised to the second power. It's in this form here where it's equal to 0, and maybe I could factor this one. The numbers don't look so bad here. It's 4, 12, and 9, so there might be a way to factor that, but if I don't even want to try to mess with the factoring, if I don't feel that good about it, I'm just going to go ahead and try to do the quadratic formula. All right, so my a in this case is 4, my b is 12, my c is 9. All right, so my solution, x, is going to equal negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, again, writing it down, saying it out loud every time you do one of these problems helps you remember what the formula is. All right, so it's negative b, so it's negative 12 plus or minus the square root of b squared, so 12 squared minus 4 times a, which is 4, times c, which is 9, and then all of that over 2 times a, which is once again 4. All right, so again, first challenge is remembering the formula, then you just plug each number a, b, and c into the correct spot, and now the next challenge is just simplifying all this stuff as much as we can. All right, so let's see what we get here. So it's a negative 12 out front plus or minus the square root of, all right, so it's 12 squared, which is 144, all right, that's 12 times 12, and then minus 4 times 9, so that's going to be minus 16 times 9, which is 144, weird, all over 2 times 4, which is 8. All right, so notice what happens inside the square root here. We get 144 minus 144, which equals 0. Right, so I get here negative 12 plus or minus the square root of 0 over 8. Well, what is the square root of 0? Well, the square root of 0 just equals 0. So I end up with negative 12 plus or minus 0 over 8. And now, negative 12 plus 0 is negative 12. Negative 12 minus 0 is negative 12. So I end up with negative 12 over 8, which then I can simplify that fraction, right, because both of these can be divided by 4, so that gives me negative 3 over 2. All right, and in this case, I just get one single solution to this equation, x equals negative 3 over 2. All right, so again, another example of using the quadratic formula. I went a little bit quicker through this one. Write down the formula, plug all the numbers in, do the simplifications. This time we only get one answer. I said previously that usually we get two solutions when we solve a quadratic equation, but there are times when we get one solution, right? The times that happens when we're using the quadratic formula is when we do all that stuff inside the square root and we end up with a 0 there. Well, negative 12 plus or minus 0 just equals negative 12. That gives us one solution, right? And also, since we ended up with a nice fraction here, negative 3 over 2, that means that we could have gone back here. If we had factored this, we would have come out, or we would have been able to factor this to get the solution. And since we have just one solution, our factors would have been 2 of the same factor. Right? This is actually one of those perfect square trinomials where I guess it would have been 2x plus 3 times 2x plus 3. So if we had factored that, it would have been 2x plus 3 times 2x plus 3, and we could have gotten our single answer of negative 3 halves that way as well. Right, I'm going to pause this here and put up one more example real quick, and we'll talk through that real quick. There's something else that sometimes happens when you're using the quadratic formula that I want to point out to you. All right, for this last example out here, I actually worked it all out because we're starting to run out of time on this video here, but we have x squared plus 2x plus 2 equals 0. Again, a quadratic equation in this form. So I write down the quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a. Plug in all the numbers, start doing the simplification, and when I do all the simplification, I end up with that square root of negative 4, and you may recall that I can't do the square root of a negative number, right? That does not give me a real number. So if you're using the quadratic formula and you end up with a square root of a negative in there, there is no solution to that equation. There's no real number that will solve this equation here, right? And sometimes quadratic equations don't have a solution that's a real number, right? If you need a solution for this, that's when you get into complex numbers and imaginary numbers, which is something we're not going to deal with right here. But that's what happens sometimes when you get no solution, is when you get that square root of a negative, right? So those are a few examples using the quadratic formula and some of the different things that can happen when you use it, right? Real important formula to know.